Hey everybody, today we're going to do trigonometry lesson number 2. In order to do this lesson, you're going to need a calculator. Now, you have a few different options as far as what to do regarding your calculator situation. You can use your phone and turn it to the side to get a scientific calculator. Most of you know that trick. Or you can use a handheld one, which I hope you have lying around somewhere. Or, in light of the times that we have now that are unexpected and different, a lot of companies are offering free stuff. And so I want to show you how to get some free stuff if you are on a desktop or laptop computer. Okay, so what I want you to do here, so if you are on a desktop or a laptop computer, and there are ways to do this for a Chromebook as well. You might not be able to go through the official website. If you do not have a graphing calculator, I want you to participate in this activity here. Now, if you do have a graphing calculator, you know, a TI 82, 83, 84, you won't have to worry about this because you can just follow along with your handheld calculator. But I want you to take a look at this process here because the TI company, Texas Instruments, TI.com, which is where I want you to go, they are offering something a little bit unusual here because of the times that we're in right now. If you go to TI.com and then you click on Products, one of the links is to Calculators and Education Technology. And because they know that a lot of people are in a bad situation where they don't have access to a graphing calculator, they are offering a 6-month free trial of the software. So if you click on that first link that pops up, it was COVID-19 support, you can click download now, and you can select software either for teachers or for students. Now I clicked the one for teachers. That was actually how I got this. I'm a little bit mad at myself. I didn't think of this earlier because I think the calculator here is a lot better than what you would be looking at through the program that you have on your computer already. But anyway, it looks to me like they also have a Chromebook solution. It says complete the form for more information. Okay, so you can actually get one for the Chromebook as well. So I guess we're pretty much covered for everything. So your options here are either to use your handheld TI calculator or to download one of the emulators right here. They will ask you for a product code, but then they will give you the product code, so it's not really hard to do. Now, if your calculator is not a graphing calculator, but you do have a TI calculator of some kind, that will do everything that we need it to do for the sake of this chapter. I don't want you to go on thinking that you've done something wrong or that you don't have the right calculator. I just want to make sure you have every piece of technology at your disposal that you can use. Okay. All right, so let's get to business here. We're going to answer some pretty significant questions here in today's lesson. We are going to learn what is sine, what is cosine, and what is tangent. Now, a lot of you, you look at your calculator, and I even hear this sometimes, what is the sine button? As soon as you say that, I know that you have no idea what you're talking about because it's actually an abbreviation for sine. So when you say sine, what's sine, then I pretty much know you're in trouble. It's an abbreviation. We call it sine. Just like if you see COS on a calculator, we call it cosine. And just like if you see tan on your calculator, it is referring to a tangent. So, I mean, obviously these are pretty important buttons here. They've even got their own spots here. We don't have to hit the second button or anything like that. Okay, sine, cosine, and tangent. Okay. Now, here's the actual significance. I'm going to scroll down here and I'm going to show you a couple of example problems. We have learned that with right triangles, if you know two sides, you can find the third. That's the Pythagorean theorem. But what if you only know one side, but you know one of the angles that goes along with it? So for instance, in this example, we know that one of the sides is 13, and then we know that the angle next to it is 71 degrees. That is actually enough information to solve for every side in this triangle. And the way we do it is with the tools that we're going to learn today involving sine, cosine, and tangent. Okay, now, what we have here, I tried to start with the easiest example that I could think of, which would be the 3, 4, 5 right triangle. All right, so you're going to see sort of how all of these things fit together. This is one of those lessons that you need to watch the entire thing, and the very first time you see it, you are going to probably not make a lot of sense of it. By the time we get to like the 4th or 5th example, right when we're wrapping up, I think you're going to feel a lot better. Okay, so give me time, give this video a chance, and take notes as you go. All right, so what we have here, this symbol right here, it's a theta symbol. It's a fairly common symbol that we use whenever the angle is missing. Okay, so we're going to talk about these ratios here using that symbol. We're going to say sine, we're going to use the abbreviation of that angle theta equals, and we call these trig ratios because it's actually the ratio of one thing to another thing. So in this case, sine is the ratio of the opposite side, write this down, to the hypotenuse. Okay. So in this particular example, and you can pause if I go too fast here, the sine of theta equals the opposite side over the hypotenuse. The opposite side is basically whatever side is farthest away. So that would be 3. The hypotenuse is going to be the biggest side. That's always the case. So that is going to be 5. So the sine ratio for that angle in the example is 3 over 5. Okay. Now we go to the next one. We've got the cosine ratio. For cosine, we use the ratio of the, we're going to use a third word here, of the adjacent side to the hypotenuse. And again, you need to give this a chance. In about 15 minutes, everything is going to make sense. Right now, I'm guessing nothing is going to make sense. Okay, so work with me here. The cosine of the angle, we're going to do this example together. Adjacent is a fancy word that we use to describe kind of your next door neighbor. You know, adjacent is something you are next to. So in this case, the adjacent side is actually 4. The hypotenuse is still 5. Okay. Then last but not least, there is the tangent ratio. The tangent of an angle is the ratio of the opposite side to the adjacent side. So in the example that we have here, the tangent is equal to the opposite side, which is 3 and the adjacent side, which is 4. Okay. All right, now why do we have to learn this stuff? What does this actually have to do with anything? Well, again, the Pythagorean theorem only goes so far. When we do problems like the one that you see right here, we can't use the Pythagorean theorem. We don't have enough information. The Pythagorean theorem is where, you're given a couple sides, and you do a squared plus b squared equals c squared, and you find the third. This time around, all we've been given is one side and one angle. This is where the power of what we just jotted down, sine, cosine, and tangent, this is where the power of that comes in. We can find the missing side. We could find either side, the one that's missing, the one that's not missing. In fact, we could do what's called solving the triangle, which is figuring out every angle and every side involved in this triangle. These 3 trig ratios are how we do it. Okay? Now, the cheesy phrase that I learned back when I was growing up was so katoa. Now, back when I was a kid, we weren't very politically correct. So whenever we were learning trig ratios, we talked about the Indian chief Sohcahtoa. Now, that's not really something that you would probably say nowadays. I don't say it to be offensive. I say it because this is one of the best cheesy ways of remembering what each ratio does. And it's actually really important that we remember what each ratio does. We need to remember that sine is the ratio of the opposite to the hypotenuse, and that cosine is adjacent over hypotenuse, and that tangent is opposite over adjacent. We need to remember those things because we have to practice every tool that we have. Okay? We have 3 different tools. We need to know when to use each one. Okay? And it's all based on the information that was given to you and what you want to know. Okay? So it's all based on what do you know, what do you want to know. In fact, that's how we are going to do things in these examples. So, in our first example, by the way, one of the things that I like to do is make a prediction, because I want to know that my answer actually makes sense. Okay, so when I look at x in this first example, it is the hypotenuse. It is big. It is way bigger than 13. My prediction is going to be, let's say, 35. Okay? Now, I do that because if it turns out that my answer is way different from 35, it means I probably set it up wrong. Okay, so I'm just throwing a number out there. You can throw out whatever number you want, but it's going to have to be way bigger than 13. Anyway, in the picture, based on the angle that you were given, the side that has been given to us is the adjacent side. Now, how do I know? Well, adjacent means your next door neighbor. Opposite means the one farthest away. And the hypotenuse is always the biggest side whenever we're dealing with a right triangle. Okay, so which side do you know? Well, they gave us the adjacent side. It's 13. Which side do you want to know? Well, I want to know the hypotenuse. Now, if you look at our ratios above us right here, the sine ratio involves opposites. We were not given opposites, which means I don't want to use sine. The tangent ratio involves opposites. I do not want to use tangent. The ratio that I want to use is cosine. you base your choice on what you want to use. What side length do you know? What side length do you want to know? And instead of using that weird theta symbol for the angle, I'm going to put in 71 because we actually know the angle that we're working with. It's 71. Okay, so according to our rule, the cosine of 71 is equal to adjacent over hypotenuse. The adjacent side is 13. The hypotenuse is x. Okay, so that's what we're at right here so far. So the cosine of 71 equals 13 over x. And again, I've already said it. You need to give this thing a shot. By about the fourth example, you're going to feel better. We're going to practice this for the next several days, so don't get overwhelmed. Now, how do you solve this? Well, I do the cheesy thing because I'm trying to build on things you already know. I just tell kids to put the cosine over 1 and then cross multiply. I know there are better ways to teach it, but right now, that's what we're going to do. So if you were to cross multiply, you would get x times the cosine of 71 equals, and then if you were to cross multiply on the other side, you'd really just get 1 times 13, which would just be 13. Now, this is where your calculator is going to come in. I just want to tell you right now, if you type in cosine of 71, you're going to get a negative number. What in the world is going on? The first thing you need to do every time, you cannot say this enough. In my case, I'm going to click on the word mode. Okay. There are two different ways that this calculator measures angles: radians and degrees. You need to go in your settings, wherever your settings are on your calculator, and you need to change to degree mode. Okay, so on this calculator, all you have to do is go down, highlight the word degree, and then hit enter, and then quit, and you're good to go. Watch what happens if you type in cosine of 71 now. Gives you a positive number. Now, you don't know which, you haven't done this before, so you don't really know that that's right, but I'm just going to tell you right now it's right. And I'll show you the significance of that number here in just a second. I just wanted to make sure we were good on calculator settings. Okay, so let's go back to our problem, and then I'll show you what this means. Cosine 71 is really just a number. So if I want to solve for x, all I have to do is divide both sides by the cosine of 71. All right. So our calculator will do it for us. We don't have any work that we have to do by ourselves. 13 divided by the cosine of 71. Again, your calculator will do it for you. 39.93. Now, if you remember, my guess was 35. So the fact that it came out to 39.93, that's close enough. So we're going to go with it. Okay. All right. We're going to keep going. Like I said, that was a very weird problem. If you have never seen sine, cosine, and tangent before, this is going to be a pretty weird 10 minutes, but I'm telling you, if you work through it, you're going to be fine. All right, next problem. The angle that we were given was 52 degrees. Now, there are two sides involved here. There's this one and there's this one. Which side do we know? Now, this is sort of my fault. I didn't mark this down as a right triangle, but it is a right triangle. Today, we're only working with right triangle trigonometry. The side we know is actually the hypotenuse. It's the longest side. Now, which side do we want to know? Well, we want to know the opposite side. Okay? So, when we're practicing getting these set up, remember, adjacent is your next door neighbor. Opposite is the one farthest away. And the hypotenuse is the biggest side. So in this example, in case you're wondering, this is the opposite. The adjacent is actually the one we're not using right now. Okay, they didn't give it to us, and we don't want it. And then the 20 is the hypotenuse. Okay. So basically, when we're going through and we're choosing what direction to go from here, we pick the ratio out of the 3 that uses both hypotenuse and opposite. Check and check. We're going to use sine. Okay. And instead of using a silly theta angle symbol, I shouldn't call it silly, you're going to see it for the next, I don't know, forever. We're going to use the angle that was given to us. And then we are going to set up the ratio in order, opposite on top, hypotenuse on bottom. The opposite side was x, and the hypotenuse was 20. Now, to solve, we're going to cross multiply here because, like I said, I don't really feel like teaching you anything new at the moment, and I already know that you know how to cross multiply. 1 times x is x, and 20 times the sine of 52 is 20 times the sine of 52. Again, so if you cross multiply, you just do this times this times this, and we are good. Okay. Now that means we have some great news. X is already solved for. All we have to do is get our calculator out and type in 20 sine of 52. And remember, if you aren't getting the same answer as me, it's probably something in your calculator settings, and I want to make sure you're paying attention to that. Anyway, what was our guess? Like, we didn't really make one yet. What's our guess? Well, if the hypotenuse is 20, then that means both of the other sides have to be less than 20. So my guess is, I don't know, 14, 15, something like that. Something less than 20. If we get something bigger than 20, then we screwed up. All right, 20 times the sine of 52 is, okay. All right, that wasn't a bad guess. 15.76. Looks good to me. Okay. Let's do a few more. I want to feel really good about this. Okay, we're not there yet, but you're going to feel really good about this. Okay, so let's take a look here. We have a little teeny 23-degree angle, and then we've got a 4 down low. So we have to figure out what we know and what we want to know. Right now, we know that little 4, that far away 4, hint, hint, if that is the farthest away side, it is your opposite side. And then what do we want to know? Well, the thing that says x on it is the thing I want to know, and that is the next door neighbor, the adjacent. Now, if you're wondering, well, why aren't we using the hypotenuse? Well, take a look. The hypotenuse is this right here. I don't know it. I don't want to know it. I really don't care. Okay? So you're just going to leave that alone. We're not going to use it. We are going to pick the trig ratio that only uses opposite and adjacent. Boom. Tangent. So we're going to use the value that they gave us, and we're going to say tangent of 23 equals, and we have to follow the order given to us. Tangent equals opposite over adjacent. So according to the order that they gave us, we're going to say 4 over x. Now, by the way, if you're looking for a prediction, that 4 is by far the shortest side. So x is going to be way bigger than 4. I'm thinking it's going to be like 10 or something. I'm just going to throw that out there. All right. So we're going to solve by cross multiplying again because I'm not going to reinvent the wheel here. So we have x times the tangent of 23, which is just x tangent of 23. And then we have 1 times 4, which is 4. Now, unfortunately, on this problem, we don't have x solved for, which means we are going to have to solve for it by dividing both sides by the tangent of 23. It's all right, not a big deal. That will cancel that out over here and over here, and the calculator will do all of the work for us, and we get 4 divided by the tangent of 23, which is, hey, our guess was pretty good. I guessed 10, it was 9.42. Not too bad. All right. Looking good here. We're going to keep on going. We're going to keep on pressing on. Let's do 2 more. Okay, so we have a 32-degree angle. Based on that angle, the side that we know is the opposite side. It is the one that is farthest away, and it is 100. Okay. Now, we also have this side over here that we want to know, which is the hypotenuse. The adjacent side is the one that we don't know and we don't care, okay? So that's not the one we're going to use. We're not going to use the adjacent side. We're just going to use the other two. So which ratio uses opposite and hypotenuse? It looks like it's going to be the sine ratio. So we are going to say sine 32 equals 100 over x. All right, now, make a little prediction here. You know, if this is 100, I feel like that should be about 200. If it were a special triangle, it would be 200. And this is really close to a special triangle. So I'm going to say my prediction is about 200. Okay. All right, we're going to cross multiply, and we're going to say that x times the sine of 32 equals 100 times 1. Oh, man. I got to divide again. All right, it's fine. So we're going to divide again, and we're going to get, if we divide both sides by the sine of 32, we're going to get 100 divided by the sine of 32. 188.71. Not bad. Not bad, not bad. The guess was 200. It was 188. That sounds pretty good to me. I think we'll go with it. All right. Last example of the day. This is weird. What is going on this time around? Take a look. We know the opposite side, but we also know the adjacent side. The question is, what do we want to know? Well, we know the opposite. We know the adjacent. We don't know the angle. The problem is we don't know the angle. That weird theta symbol is back. They never gave us the angle, but they gave us two sides. Well, according to our rules, opposite and adjacent both come together in tangent. Okay, so we've got tangent of theta equals, the opposite is 5, the adjacent is 7. So how do you go backwards? If you're given two sides, how do you go backwards to find the missing angle? Well, it turns out you can work in reverse. It's called the inverse, actually. And in this calculator, it's in blue. So if you hit the blue second button first, and then you hit the tangent button, it puts a little teeny -1 right there. That is the symbol for an inverse function, which means we are doing tangent, but we're doing it in reverse. So if you do the inverse tangent, and then you put in the two sides that we know, 5/7. So basically we know the ratio. We're just going to work backwards. And if we do that, it gives us the measurement of the angle. So it turns out the angle we needed was 35.53 degrees. Okay. So we're going to practice that a whole lot. We're going to practice both using tangent and the tangent with the little -1 symbol, which means the inverse tangent. We're going to practice both of those as we go. Okay, so the key to that problem was if the angle is the thing that is missing, but you're given two sides, you have to work backwards and you have to use the inverse. Okay, and that will work for sine, cosine, and tangent. There's an inverse for each one. Okay. All right, so that's all I got for today. We are going to practice this for the next couple of weeks. It's not going to go away. We're going to practice it. We're going to get really good at it. We're going to build on it, and you're going to be all right. So if that was a lot for you to handle and all you did was write down the notes, that's great. We're going to build on it. We're going to get better. In the meantime, hope you have a good day. Thanks for watching. Take care of yourselves and each other.